Okay, we're going to do the third CVPM practice problem, again algebraically. Okay, so we have a missile approaching a base, moving 450 meters per second. We're trying to launch a second missile that will intercept that one after it has a short delay to figure out where the incoming missile is. So the missile coming in is fine, but the missile going out would have to speed up in order to get to, even if it ever flies with a constant velocity, it still has to speed up from 0. So that would not be in agreement with CVPM, though if that happened relatively quickly, our prediction might be close enough to be usable. Okay, so we want to know how fast the missile needs to travel in order to intercept the incoming missile before it gets closer than a kilometer to the base. So we'll draw a picture here. So here's our incoming missile. We'll call this incoming. And it's moving with a speed of 450 meters per second. Again, I'm going to ignore the signs here, or not ignore, but we're going to work with speeds and distances rather than velocities and displacements, because we're going to make the signs work out more easily. We can make them work out either way, but okay. It's going to be hit here by the smaller missile, the outgoing missile. And we're not quite sure how fast that one's going, but whether it's faster or slower than the other one. Okay, what else do we know here? So this missile is going this far. The incoming distance we actually do know. It's going to be going 5 kilometers, and the outgoing one is going to be going a kilometer. Okay, let's measure from the tip of the missile to the tip of the missile. We always have to measure to the same part of the object each time. There we go. Now the distance between them overall is 6 kilometers. So that was a super easy little subtraction. It's okay if we do that non-symbolically there. Anything even slightly involved, we're going to do symbolically. That was super easy, so we're okay with that. Okay, so CVPM will tell us that the distance the incoming missile goes is VI times delta t. The delta t for the two are the same, but they're not the same actually. So for the incoming one is unknown. For the outgoing one, what I know is that it's the same as the ingoing one minus some delay, and I'll call that delay big T, so that I don't have a third delta T in here. But basically, the idea is that this missile travels for 3 seconds fewer than the other one. So the outgoing missile is V outgoing times delta T minus T. Okay. So I could have either done this by figuring out how far the incoming missile goes in that first 3 seconds, and then saying that they traveled the same distance, but the incoming one started at a different place. Or I could do this and say that they're traveling different amounts of time. So that's just what I chose to do this time. If we look at these two models here, we know the distances, we know one of the V's, and we don't know that delta T. Since I'm trying to find the V, I'm going to eliminate that delta T. So I'll solve for it over here and substitute it in over there. And then solve. Oops, copied that one wrong. Okay, so this is a fairly involved expression. We'll have to be careful to check our units here. Okay, distance of the outgoing missile is going to go 5 kilometers. The incoming one went 1 kilometer. Oh, I'm sorry. 1 kilometer. The incoming one went 5 kilometers. And the incoming one is going 450 meters per second, minus 3 seconds there. Alright, so we have a problem here because these units are going to cancel in a funny way, kilometers and meters per second. So, what that tells us is that we should go back and use meters instead of kilometers. Now our units will cancel nicely. So in the denominator here, we have the meters canceling and the seconds going up to the numerator. So this fraction is in seconds, subtracted, that's in seconds, that's good. You can't add or subtract two things that have different units. So we have meters divided by seconds, and that's exactly what we want. So we'll plug in the numbers. And we get that we only need 123 meters per second of speed here. So really that's plenty. It has plenty of time to catch at 123 meters per second. It's not too fast for a rocket, so this would be possible. Actually, the hard part about this is hitting the target, not getting it to go fast enough.